Good morning, Jaguars. Alright, so this is what I have for today. Just to go over your goals for the week. Make sure you can get into the following technologies from home. You will need them in the coming weeks. We have Google Classroom, TCi, Zoom. Some people have been asking about how to get in. If you're having trouble getting in, when you first get in, it puts you into a waiting room, and then I will let you into the main conversation after I see that you're in the waiting room and I know who you are, so I'm not letting just random people in. Also, Schoology, work on getting into Schoology. Once you get in, some people are saying the access code doesn't work. It turns out you don't actually need the access code. You should just be able to click on the link and you'll be there. You won't see anything. It won't be fancy. You'll just see your class, and there's no assignment. But once you get in, make sure that you're able to get in. Let me know if you cannot get into one of these so I can help you figure out a solution. You do need a computer for things like TCi and Schoology. Those things are not going to be able to be done on your phone. If you don't have a computer, you need to talk to the district and see if they can get you a loan or a computer, because otherwise these are going to be very difficult to do without a computer. Some of the things like Google Classroom, you can check certain things on your phone, you can do some edits, but those are obviously easier on a computer also. Zoom you could do on a phone or on a computer or a tablet, but really the best option is a computer. There are more features available on a computer. Most people have figured out Google Classroom, TCi, and Zoom. We're going to do another Zoom video conference on Friday at 1 p.m. Based on my survey, most people are available at 1 p.m. I will look at who is available at other times that can't do the 1 p.m. time, and I will contact you separately for another conference so that I know that everybody can get in. Once we start doing regular Zoom meetings, I will try and make ones that are maybe 2 different times so that people that have different limitations can get into those conference meetings. Alright, other problems, let me know. I want to make sure that you guys are able to get into all these things that you need. Alright, topic of the day is Earth satellites. So obviously we have the biggest satellite, that is the moon. We got a great big moon. But we also have various man-made satellites that are going around our planet. And today at 10:45 they're going to start the countdown for a military communication satellite that's launching. It's actually the first launch under the command of the U.S. Space Force. It's the 6th in a series of 6, so it's the very last one of these satellites. The other ones are already up there. They're already orbiting the Earth. This is the 6th and final one. It's going up there. They're going to launch at 10:56 a.m. this morning. The countdown, if you can log in for the live stream of it, you can start around 10:45. It'll start then, and you can hear them talking about it. And I'll put the link for that. So tell you a little bit about what a geostationary satellite is, because these are geostationary. They're military satellites. They're communication satellites, a lot like our GPS. GPS is a satellite system that tells us where you are on the Earth, and there's a whole set of them that tells your phone where you are. It's telling where you are. It's geography. So with this, we're going to look at a globe. So let me set up my camera here. Alright, so we have our globe. And we have the globe orbiting, right? It's orbiting the sun and it's rotating. Rotating. It goes around on this rotational axis about once every 24 hours. Just a little bit less than 24 hours. Now here we have a rock. This rock is going to be our satellite. Now, if you put this up here and you have it rotating like this, then it's going to be passing over all of the different continents and oceans as it goes around. That's not geostationary. That's traveling in a different pattern than the Earth. To be geostationary, you want the satellite to travel at the same rate of rotation as the Earth. So while the Earth spins, it's spinning. Now, if you were on the equator and you were tracking how fast you were going, the land at the equator is traveling about 1,000 miles per hour as it goes around. So you are actually going pretty fast right now. You don't feel it because you're already on the planet and you've already been going this speed your whole life. But if we move further above the equator, so we're going higher and higher altitude away, as we travel around, we actually have to travel faster, cover greater distance as we're traveling in order to keep up with how fast the Earth is going. So while on the equator you might be going 1,000 miles an hour, to move up to where these geostationary satellites are, they're going 7,000 miles an hour, and they're keeping up and they're staying in the same place. So this set of satellites that we're looking at today, looking at it from the top of the globe, there's going to be 6 of them placed all around the world, mostly over habited lands, right, so that we can see what's going on with people in different countries. These are 6 geostationary satellites which will travel at the same rate of speed as the planet itself. I'll put some links in here that you can learn more about geostationary satellites and the launch that's coming later this morning. Hope you're able to tune in and watch a little bit of it, and hope you guys are doing well. Stay safe, stay healthy, and I'll talk to you soon. Bye-bye.